In today's lecture, we discuss the design of the biological unit processes treatment, right? Basically, the biological unit processes are classified in two types. The first is aerobic biological unit process, and the second one, which is the anaerobic biological treatment process, right? Basically, aerobic biological unit processes are again classified in two types. The first, which is activated sludge process, and the second one, which is trickling filter, right? And the anaerobic biological unit process, which is classified in one type, which is sludge digestion type. Now the next one, which is the figure of the trickling filter, are there. Basically, it is known as attached growth process, right? It is also known as attached growth process because of wastewater enter through the central pipe and then comes and then enter to the nozzle at top of the tank, right? After that, wastewater is spread into the stone media through the nozzle. Then the microbes present in the wastewater, which attach itself to the stone media and grow in a multiple manner, right? So the layer of the microbe which attach to the stone is known as a slime layer. And the point comes where the layer of the microbes grows in the thickness such that the entire layer which is fall down along with the wastewater. So this process is called as a slime layer or the slugging of slime layer. Now the next one, which is here on screen, you can see that the real-time image of the trickling filter are there. Okay, here this is a stone media, this is a stone media are there, this is a center pipe of the trickling filter are there, right? Now the next one, which is the types of the trickling filter. Basically, the trickling filter are classified in two types. The first one, which is the conventional type trickling filter, and the second one, which is the high rate trickling filter, right? Basically, when entire amount or some part of the wastewater is circulated back into the trickling filter, it is known as a high rate trickling filter. Now, some important terms for the trickling filter, it is used for the design purpose, right? Okay, the first one, which is the hydraulic loading rate. So what do you mean by hydraulic loading rate? It means that it is a discharge per unit plan area of the filter, and it is denoted by million liter per day per hectare. Okay. Now the second term, which is the organic loading rate. So it is the kg of BOD applied per day per unit volume of filter. It is known as organic loading rate, and it is described, it is denoted in the kg per day hectare into meter, right? Now the next one, which is recirculation. Okay, what do you mean by recirculation? It means that a part of whole discharge of wastewater is sent back to the upstream. It is called as a recirculation, and the recirculation ratio, which is R by I, where R is equals to wastewater recirculated discharge and the I, which is equals to raw wastewater discharge, right? Now the next one, which is the difference between the conventional and high rate trickling filter. Okay, so the basic difference, which is the first is hydraulic loading rate. In the conventional trickling filter, the hydraulic loading rate, which is 20 to 40 million liter per hectare per day, and in the high rate trickling filter, it is take a 110 to 330 million liter, right? Then organic loading, it is conventional trickling filter, it take a 900 to 2200 kg per day per hectare. In the high rate trickling filter, it is a 6000 to 18000. Then depth of filter, in the trickling filter, the depth which is 1.6 to 2.5 meter, and in the high rate trickling filter, which is 1.2 to 1.8 meter. Then design interval for the conventional treatment, which is 5 to 10 minutes, and dosing interval for the conventional trickling filter, which is 5 to 10 minutes, where in the high rate trickling filter, it take a not greater than 15 seconds, right? Quality of secondary sludge, which is black and oxidized in the conventional system, and the black and it is not oxidized in the high rate trickling filter. And the last one, which is recirculation, does not occur in the conventional trickling filter, and it is a mandatory in the high rate trickling filter, right? Now the next difference, which is the difference between the trickling filter and the activated sludge plant. Okay, so here the basic difference are given for that. In the trickling filter, bacteria will grow on the surface of the stone, and where the activated sludge plant, the bacteria will grow in the wastewater in the suspension form, right? Then BOD removal, which is 70 to 80% in the trickling filter, where in the activated sludge it is 90%. Then initial cost is very high in the trickling filter, and the activated sludge plant, the initial cost is less. Then skilled workers are needed for the trickling filter, and the skilled workers which is not needed in the sludge plant. Then use when wastewater discharge is very high, and the activated sludge plant is used when wastewater discharge is very low. The no dark foam layer which is found in the trickling filter, and the dark layer which is found in the sludge plant, and the aeration is not required in the trickling filter, and here the aeration process is mandatory, right? Now the next one, which is the design step of the high rate trickling filter. Okay, so basically the first step, which is BOD of the influent in kg per day, right? Find BOD of influent in kg per day. Now the second step, which is assume percentage of BOD, remove PST in the primary settling tank, and the remaining entering into the high rate trickling filter, right? Now third step, which is the find BOD of effluent in kg per day, right? Now the step 4, which is the find efficiency of filter. Then step 5, the find recirculation ratio, and the step 6, which is assume the depth. Then step 7, which is find the area. Step 8, which is find the diameter. Okay, so these are the basic steps for the design of high rate trickling filter, right? Now the next one here, the example of the trickling filter are that. Okay, so the data which is design a high rate trickling filter for a flow of 4.5 mld million liter day if the recirculation is 1.5, right? So the recirculation ratio is given. Then BOD of wastewater, which is 250 mg per liter, and the final effluent desired, which is 30 mg per liter, and assume the suitable data. Okay, so first of all, we find out the BOD present in the wastewater. Okay, so discharge which is given, flow which is given 4.5 mld, right? And the BOD which is influent BOD which is 250 mg per liter, and effluent BOD which is 30 mg per liter, right? And the ratio which is 1.5. First of all, we find BOD present in the wastewater, which is 4.5 into 10 raised to 6. We convert kg per day into 250, right? Because here the BOD are given. So the answer will be the 1125 kg per day, right? Now, assume BOD removed in PST, primary settling tank, which is 30%, right? This is a standard value, right? So the BOD entering into the high rate trickling filter, which is 70%. So the 0.70% into here we find a BOD present in the wastewater, which is 1125, right? So the final answer, which is the 787.5 kg per day, right? Now the next one, which is the BOD of effluent, which is given 30 mg per liter, right? So first of all, we find BOD of effluent in total wastewater. So the 30 mg per liter is given into the flow of water, which is 4.5 mld. Again, we convert into kg per day. So 4.5 into 10 raised to 6 into 30 mg per liter, which is also converting to the kg per liter, right? So the answer, which is, so the 30 into 10 raised to minus 6, right? So the answer, which is the 135 kg per day. Okay. Now the step number 4, which is the BOD removal efficiency. So the equation for the efficiency, which is BOD influent minus BOD effluent divided by BOD in the fluent into the 100, right? So the influent which is value which is 787.5 minus BOD effluent which is 135, we find out, right, into 100 divided by BOD influent which is 787.5. So the efficiency which is 82.85%. Now the next step which is the recirculation ratio which is given 1.5. So the recirculation factor, and before that the equation is given. It is a standard equation for the recirculation factor. F is equals to 1 plus bracket R by 1 divided by 1 plus 0.1 bracket R by 1 whole raised to whole square, right? So the R is equals to R by 1 is equals to given. So here the 1.5. Then again here the R by 1 the value which is given 1.5. So the answer which is 1.89. So recirculation factor which is 1.89. Now the next one which is efficiency is equals to 100 divided by 1 plus 0.0044 under root of y by vf, right? So here we find a velocity. So here the equation of the efficiency are given. So from this equation we find a velocity. So here we put the data into the equation and we got a value which is the 1882.8 meter cube, right? Now the assumed depth which is 1.5 meter. So the area is equals to V by D. So we find the area V which is 1882.8 divided by we assume the depth which is 1.5. So the final answer which is 1255.21 meter square, right? So this is the area, this is the value of the area which is 1255.21 meter square. Now we find the D, actual diameter of the trickling filter. So now we have an area which is 1255.21 meter square. Okay, so area is equals to, for the circular area the equation which is A is equals to pi by 4 d square, right? Now we have a value of area which is 1255, and from the area we can find the diameter of the trickling filter. So the D is which is equals to 39.47 meter. So this is near about the 40 meter. So we provide a diameter which is 40 meter. So answer which is the provide high rate trickling filter with 40 diameter, 1.5 meter depth, and the recirculation ratio which is 1.5. So this is the basic design of the high rate trickling filter. So this is the all about the today's lecture. I hope you all understood about the today's lecture. Thank you for the watching. Thank you.